All right, everyone. I wanted to try making a video right now. And so for this video, we're going to go over the outline. That's going to be covering the topics for your test on Thursday. Um, so let me show you what the outline is. And again, I'll post the outline on both Blackboard and on Pearson. And so here's the outline. And this essentially is what we're going to be covering for your test. It starts chapter 4, goes all the way to chapter 5. Okay. And so topic wise, we started off with vector spaces. Okay. And so the main thing on vector spaces is can you tell if a given set of vectors and with the two operations, vector addition and scalar multiplication, forms a vector space. So this means showing all 10 axioms are actually going to be true. Again, so this one, expect them to be not your standard basis or standard vector spaces, right? So don't expect it as like R3 or your PN or your matrices, right? So more likely than not, I will either change the set of vectors or I'm going to change how to add them or how to multiply scalars with the vectors, right? So that's more likely what's going to happen is I'm going to have to change the operations on how to add them and how to do scalar multiplication. And then you have to determine if the set of vectors with the two operations are going to form a vector space, right? So you don't have to memorize the 10 action one. It's obviously going to be taking this at home, so you'll have a copy of it. And I will put it on the test as well, so that way you can sort of just see what the 10 actions are on there. Now, part of the vector spaces, we did go over a basis. And so for this one is if I gave you a set of vectors, can you tell me if those set of vectors forms a basis? So you're gonna have to show work, right? So you can't just say a yes or a no answer. So you actually have to show the two things that makes it a basis, which is it has to span and it has to be, or they have to be linearly independent. So make sure you're able to determine if a set of vectors forms a basis for something that we know is a vector space. Now, sort of a part of the vector space, it's the subspaces, right? So determine if a subset of a known vector space forms a subspace, right? So remember, there are three things you do have to show if it is a subspace, right? So one, it is closed under vector addition. It is closed under scalar multiplication. And then third is that the zero vector has to be part of it. And so if one of those fails, then your subset with the operations does not form a subspace, right? So that's one thing that you want to make sure for subspaces you know how to do. Um, Finding a basis of a subspace, right? So in this one, we are talking about sort of basis from your sort of subspaces that you form from your matrices, right? So there are three that you want to make sure you know how to find. So your row space, your column space, and your null space, right? So remember, all three of them can be done doing reduced row echelon form. Again, you can use your calculator on this one, for right? So I don't expect you to show the work on how to do the Gauss-Jordan or the row operations to get there. So all you have to do is really just use your calculator and then make sure you know how to find each one, right? So column space, row space, and null space. And then the rank of the matrix as well as the nullity, right? So those are essentially the dimensions of your subspaces. So namely for your row space, column space, and then your null space. So we already talked about the basis, right? So basis vectors, or if a set of vectors forms a basis. Now the main thing on here is the coordinate matrices, right? Or the coordinate vectors. Um, and so make sure you know how to find those, right? So really those are linear combinations. And so if they are bases, right? So that means you should be able to span your vector space. And so which means, right? So any vector in your space should be a or should be written as a linear combination of your basis vectors. So if it is, then the coordinates or the coefficients are going to be the coordinates, and that itself forms a vector. So make sure you know how to find that. as well as the change of basis, right? So we talked about this towards the end of chapter 4. And so how do you go to find the coordinates from one basis vector to another basis vector? So that's finding your transition matrix from a basis of B to, let's say, B prime, as well as being able to transform a coordinate vector or matrix from one basis to the other basis, right? So make sure you know how to do that, right? That's the two things right here for the change of basis. So make sure you know how to do it. And then lastly, sort of transformations. Um, and so make sure that's sort of just still part of the subspaces right here. So kernel, range of the transformation. So those are essentially your column space. The kernel is the null space, and the rank and nullity are just sort of dimensions of the row space and column space. Now, as far as the chapter fives are concerned, right? So chapter 5, so there are essentially new topics that we went over. So namely, the first one is eigenvalues and eigenvectors. Now, the main thing on here is obviously you should know how to find them. Okay. And again, remember when you were doing your homework, 5.1 does something, 5.2 does the other one. Really, here you just have to find them, right? So if I gave you an n by n matrix, make sure you're able to find both the eigenvalues and the eigenvectors. And then sort of the one application that we sort of use this on is the diagonalization and the powers of a matrix. So those are essentially the last sort of thing on chapter 5. Again, we're going to see eigenvalues and eigenvectors later on. But as far as this is concerned, right? So as far as your test is concerned, this is the last thing on there. So make sure you're able to find this. Now, obviously, you have to show your work on these, and then I'll tell you more about instructions on how to turn in your test on both Blackboard and on Pearson. Okay. All right. So I'll see you um, probably next week for the lectures. And so just again, always keep checking Blackboard and Pearson for instructions on um, how those are going to go either remotely or both in class as well.